In this video series, you're learning Pygame by building a Brickout game. In the last video, we programmed a bouncing ball, which required boundary checking and transparency. In this video, we're going to put a player-controlled paddle at the bottom of the screen. This is Brickout 3.0. All code from this video series is available in my GitHub repository. There's a link in the description. You've already learned everything you need to know to draw a paddle at the bottom of the screen. Pause the video for a moment and do that. Doing it yourself will help to solidify your knowledge. How'd you do? To make a paddle, we'll need a surface to blit to the screen, and it will help us add motion later if we store the coordinates in x and y variables. I'll annotate three variables, paddle of type pygame.surface, and paddle x and paddle y for the coordinates of type int. Let's put this in the center of the screen, a little bit up from the bottom, and let's make it 100 pixels wide by 20 pixels high. I'm going to create the surface after I create the circle in the background. Let's call that area of the program asset setup. So paddle equals pygame.surface, open paren, 100, 20, close paren. I'm going to make it blue, so paddle.fill 00255. To put the paddle in the middle of the screen horizontally, I'm going to set paddle x to screen.getWidth divided by 2 minus paddle.getWidth divided by 2. Remember, the blitting coordinate is the left side of the surface being blit, so I want to subtract half of its width if I want it centered. And I'm going to set paddle y to screen.getHeight minus paddle.getHeight times 2 because that feels like a comfortable distance from the bottom to me. Remember that the top of the screen is 0, and the bottom is screen.getHeight, so I'm subtracting a little bit if I want the paddle to be drawn above the bottom of the screen. And we will blit it down in the drawing area at the end of the game loop, screen.blit paddle, paddle x, paddle y. The order of the different blits to the screen is important. If you think of the game as a movie, each time through the game loop, we're constructing one frame of the movie, and we construct that frame by building up layers. So we first blit the background to the screen, and then we can blit the ball and the paddle. Whichever we blit first will appear behind the other if they overlap. They will overlap when the ball bounces in the same part of the screen that the paddle is located. Right now, it doesn't matter. Just make a note of how the screen image is built from layers, and one layer can obscure or partially obscure another. And if I run that, I have a blue paddle at the center bottom of the screen. Let's give the player the ability to control that with the arrow keys. To do that, we want to check each time through the game loop whether either of the arrow keys is pressed. If they are, we want to move the paddle in the arrow direction, and if they aren't, we want the paddle to be still. Let's add a paddle dx variable, an integer, and I'll give that a value of 10. And then, after the event loop, we'll get something like a list of booleans representing all of the keys that might be pressed, true if the key is pressed, and false otherwise, with keys equals pygame.key.getPressed. We can then index into that list with the pygame.key constants for the keys we're interested in. The pygame.key constants can be found in the key documentation. We're interested in pygame.k_left and pygame.k_right, the left and right arrow keys, but you can check for any keys if you'd rather use A and D, for example. I'll write if keys sub pygame.k_left, paddle x minus equals paddle dx. If keys sub pygame.k_right, paddle x plus equals paddle dx. So if the player is pressing the left key, we'll subtract the paddle dx from the x coordinate, moving the paddle left. And if they're pressing the right key, we'll add paddle dx to the x coordinate, moving the paddle right. And I'm not using elif here, so holding down both keys cancels out any motion. Now, technically, that variable keys is pygame.key.scanCodeWrapper, but we can treat it as a list of bool, so I'll annotate it properly, but put a little note after it. Let's run that. I'll hold the right arrow key down, and the paddle moves, right off the screen. What did we forget? We forgot boundary checking. Pause the video and see if you can add the boundary checking in. Look at the boundary checking for the ball if you want a hint. How'd you do? I'm going to check the left boundary only if the paddle is moving left. So if the left key is pressed, after changing paddle X, I'll check if paddle X less than or equal to 0, and then if so, I'll set it to 0. We won't be doing any bouncing, so that's it. I'll just stop it at the left side of the screen. And then if the paddle is moving right after adding paddle dx to paddle x, I'll check if paddle x plus paddle get width, so the right side of the paddle, greater than or equal to screen.getWidth. And if so, I'll set paddle x to screen.getWidth minus paddle.getWidth. And if I run that, I'll just hold the right arrow key down, and the paddle stops at the right of the screen, even though I have the key pressed. And I'll try the left, and the paddle stops at the left. Perfect. We can apply the same boundary checking logic to any object in our game. Let's add another key press behavior for practice. Suppose we want to make the paddle sparkle while the user is holding down the spacebar. Let me give you some of the code first and see if you can add the behavior, but if you like, see if you can do it without any help at all first. To make the paddle sparkle, I'm going to create another surface called sparkles, and I'm going to create that to be the same size as the paddle. I'm going to set the color key to black, and then in the drawing area, I'm going to blit it after the paddle to the same location. So that will blit over the paddle, but it's black, and its color key is black, so no pixels will get copied. If I run that, no change. Now, to get sparkles, I'm going to draw 50 randomly sized, randomly colored circles on the sparkles surface. So for I in range 50, and then pygame.draw.circle. The first argument is sparkles, the surface to draw on. The second argument is color. I'll generate random red, green, and blue values between 0 and 255. The third argument is center. I'll generate a random value between 0 and the width of sparkles, -1, to keep it inside the surface, and 0 and the height of sparkles, again, -1. And the last argument is radius. I'll make that a random value between 1 and the height of sparkles divided by 6. Now when I run it, the paddle fills up with colored circles, and then the colored circles appear to sparkle. So it is sparkle encrusted. If you'd prefer that we can see the underlying blue, clear the surface by filling it with black before adding the circles. That will reset it each time through the game loop. Honestly, I think it looks cool both ways. The key code for the spacebar is pygame.key_space. Can you fill in the last piece of the puzzle so the paddle only sparkles while the spacebar is pressed? Pause the video and give it a try. How'd you do? The last piece of the puzzle is to check if keys sub pygame.key space and indent our sparkle drawing code there, and then add an else to reset sparkles back to basic black, sparkles.fill000, so that when the player releases the key, all of the pixels in sparkle are the color key value, black, and they do not get copied to the screen. Let's look at another way to handle keyboard events that is useful for one-time changes, not continuous behavior. Suppose we want to handle an arrow up key press by changing the background color. The best way to do that is to handle a key down event in the event loop. A key down event will be placed on the event queue when the player presses a key on the keyboard. So in my event loop, I'll add elif e.type equals pygame.key down. And then under that, I can check if the key that was pressed was pygame.k_up, the constant for the up arrow. Different types of events have different information stored in them. We used the position of the mouse in the mouse button up event to change the position of the square. Mouse events have a pause field. A key down event doesn't have a pause field because that wouldn't make sense for a keyboard event, but it does have a key field. So I will check if e.key equals pygame.k_up. And if so, I'll fill the background with a randomly generated color. If the player doesn't like the color, they can keep pressing the up arrow until they get a color they like. Now, when I run the program, pressing the up arrow gives the game a one-time change. And I can do it whenever I like. So to summarize, we use an event when we are interested in a one-time change. We use getPressed when we need to know if something is currently happening. In the next video, we're going to learn about sprites and groups, which will make collision detection easy. But until then, I'll bet you'd like to be able to hit the ball with the paddle. So, as a bonus, let's do that now. Think for a moment about what it means for the ball to hit the paddle. We have two surfaces, each with an XY location and a width and a height. For the ball to hit the paddle, its bottom needs to touch the paddle's top, and part of the ball needs to be within the paddle's rectangle horizontally. We might also wish to stipulate that the ball is moving down, so dy greater than 0. It's going to be a long logical condition, so let's break it into pieces. First, the ball needs to be moving down, so if dy greater than 0. Second, the ball is starting to overlap with the paddle vertically. I'll add and y plus square.getHeight greater than or equal to paddle y. Finally, the ball is within the paddle's rectangle horizontally. I'll add and x plus square.getWidth greater than or equal to paddle x, and x less than or equal to paddle x plus paddle.getWidth. So if all of that is true, then we'll multiply dy times -1, and we'll set y equal to paddle y minus square.getHeight, making perfect contact between the two surfaces. At this point, you've built the core of a real game: movement, control, and interaction. Now, this will look better if the ball is smaller, and of course there's not much incentive to hit the ball because it just bounces off the bottom of the screen anyway. So for homework, and these suggestions are all optional, make the ball stop if it hits the bottom of the screen. To practice with events, change the ball color if the user presses the down arrow key. Change the keys that we're currently handling from the arrows to ASWD. Add another continuous change effect to the game, like growing the paddle a little bit, up to a certain threshold, for as long as a key is pressed, and then resetting to the original size when it's not pressed. If you get stuck or want to share your successes, drop a comment below. I look forward to seeing you in the next video. And as always, have fun and keep coding.